Hello and welcome to my channel. This is the third video about the projectile motion problems. I will go along the very basic first and second problems. Now we move into a little bit more complicated question. Okay, so first let's understand what the problem has given us and what they ask us to solve. Okay, so firstly look on to the problem. Say that okay, say a quarterback A kicks a football toward a receiver B is here, who is initially positioned as shown in the figure. So the receiver moves at a constant speed of 7 yards per second and catches the ball when it reaches the height about 6 feet above the ground. So then when the quarterback needs to ensure that the receiver catches the pass exactly 2.5 after the kick has started. Okay, so the ball is released from a height around 7 feet, shown here at the moment of the kick. Okay, now firstly the point A and B, receiver and quarterback, has about 35 yards away. They asked us to determine the necessary velocity and angle to this part to complete it successfully. Okay, so look at the problems. First, we have to visualize what will happen. Okay, so surely the ball will start from A to somewhere in front of B, and as after the kick start, it should be roughly how the motion is going to be. So the ball will reach and the receiver will catch it in time somewhere above in front of point B at the height of 6 feet above ground. Okay, so with that being said, we call this one point C, for example, and this happened after 2.5 seconds as the question said. Okay, now looking into solve it numerically. First, we put on, again, firstly, before doing anything else, put on reference frame of y and x-axis and the gravitational acceleration here, so that we can know which value is positive sign, which value is minus, according to this reference. Okay, firstly we try to determine the distance horizontally of the receiver. Okay, receiver start from B to point C. Surely there should be some distance in between. So a simple equation, distance equal to velocity times the time needed, and we call this subscript R because as short for receiver. Now the problem said that it travels with 7 yards per second. So that means if we multiply this, should be the distance from B to C will be around 17.5 yards. Okay, you notice that the unit is not consistent again, but this time I will keep using yard until I have to change it. Okay, but you will see exactly when do I need to change this unit, but for now yard is good for me. Okay, 17.5 yards here. So that means we know the distance from the horizontal distance travel of a football from point A to point C, which is these two combined. Okay, now, simply determine the horizontal distance, like I mentioned. Okay, we know that the horizontal distance is 35 plus 17.5, but we have to distribute the velocity of a football, initial velocity. So okay, Vx, or velocity in horizontally, will be equal to V0 times cos theta, just like in the second question. Okay, so we distribute the velocity, we call it Vx here, and we substitute back onto the first equation. So Sx now is about 52.5 yards. If I convert it, will be 48 meter. So again, bring out the equation, substitute the distance, velocity, and time. We will left with v0 times cos theta equal to 19 meter per second. Okay. Now again, we need to have one more equation that involve with v0 or theta to solve this one. Okay. So from the distance horizontally, we left with equation 1. Now you may already guess what this will be. The next one is the distance in vertical axis. Okay, so in vertical axis, it's simply from 7 feet to a little bit lower of 6 feet. Okay, so that means we put on this equation s equal to ut plus 1 over 2 t at square, and we call it sy subscript f, which is a football, in short for football. We know that if we distribute the initial velocity vertically, we will left with vy, and that vy will be equal to v0 times sine theta here. Okay, now and for the sy, we draw a line from point C that the ball was received. Then we will left with slightly lower than the initial location, which is minus 1 feet. If in metric SI unit will be 0.3 meter, and again minus sign should be here because it's go opposite direction to the positive y, as I mentioned. So we substitute what we know. Okay, minus 0.3 as the distance, and gravitational acceleration here minus psi also, and v0 sine theta. Okay, now if we compute this one, we will left with equation 2, which is v0 sine theta equal to around 12 meter per second. Now we notice that equation 1 and equation 2 have some similarity. Okay, it contains v0, it contains theta, but how do we solve this one? Okay, so if we saying that we use equation 2 divided by equation 1, it should give us some idea. Okay, so to determine angle theta, I put equation 2 above equation 1, and you can see that v0 is the same, right? So we cancel out those two, and then we left with sine theta over cos theta, which would be tan theta, okay, equal to the right hand side 0.63. Then again we do the arctan, and then we left with the theta equal to roughly 32 degrees. So now the question not only asks about the theta but also the initial velocity. Okay, we know that equation 1 and 2 consist with v0, so we can plug in whichever we find convenient. In this case, for example, I plug in equation 1 and we get the v0 cos 32 equal to 19, and make calculation. We left with v0 equal to 20 meter per second or 47 feet per second. That is the answer for this question. Okay, and that's it. That's the end for this question. I hope you guys enjoy this tutorial video, and don't forget to stay tuned for the next one with more projectile motion to come. And again, thank you for watching. I'll see you guys in the next question.